Hey folks, welcome to my channel number 10. So today we are going to look at integration by parts, right? So what do we mean by integration by parts? If u and v are two differentiable functions, then we have integral of u dv equal to uv minus integral of v du, right? So what we're going to look in this particular video is how do we arrive at given identity what we have written down in our screen, right? Now you might recall that in every video of integral calculus that I have solved so far, I would have mentioned that whenever we've been given integrate the following with respect to x, what we have been given is dy by dx, and we've been asked to find y, right? So what does that actually mean? This is what it means, right? Integral of dy by dx times dx equal to y. So in all those problems we have solved so far, what we've been given is dy by dx. And when you've been asked to integrate dy by dx with respect to x, what we are doing is integral of dy by dx times dx, right? So I'm going to connect this with the integration by parts identity for integral of u dv equal to ub minus integral of v du, right? What if my y is a product of two differentiable functions, u and v, right? So my y equals uv, right? Now I also know from the product rule of differentiation that when I differentiate this on either side, which means I apply the product rule of differentiation, dy by dx equals d by dx of, now my y is equal to uv, and I want you to recall the product rule of differentiation. This is nothing but v du by dx plus u dv by dx, right? Now we have this, from the product rule of differentiation. Let's go to the next step and integrate this on either side, right? And when I integrate this on either side, what happens to my LHS? My LHS is nothing but integral of dy by dx times dx, which is equal to y, which is nothing but equal to uv, right? And then I go to my RHS. I apply the sum rule of integration here. Therefore, my RHS becomes integral of v du by dx times dx plus integral of u into dv by dx times dx, right? Now we have one expression on our left, which is nothing but my uv, and then we have the first expression in the right, which is nothing but integral of v du by dx times dx, right? Now my v is a function of x, my u is also a function of x, right? And I can cancel out the dx in the numerator with the dx in the denominator, and what do I get? I get v du, right? I apply a very similar approach to the second expression, which is integral of u dv by dx times dx. I again cancel out my dx, which means I'm left with integral of u dv, right? So my uv equals integral of v du plus integral of u dv, right? And therefore, when I rearrange this, right, I can rewrite this particular identity as follows. My integral of u dv equals uv minus integral of v du. So this is how we arrive at the identity for integration by parts, right? And I'm not going to discuss a specific example in this particular video, and I would request you to stay tuned to my channel to look at my subsequent videos where we will deal with problems of varying complexity involving integration by parts, right? I hope you found my content useful. Please do subscribe to my channel and support. Thank you.